Hello class, this is Mr. Hart. In this podcast, we want to continue our discussion of circle geometry, and we want to be able to find some different values of a circle. Okay. One of those very basic values is the circumference, which you've probably seen before, but let's quickly review the formula that we use to find the circumference. The circumference is equal to 2 pi r, or 2 pi times the radius. Okay, so in this formula, this c is circumference, okay, and this r is radius. Okay, so it's a pretty simple formula. We just find the radius of that circle, times it by 2 pi, and that gives us the circumference. Okay, and again, the circumference is that distance all the way around the circle. Okay, let's just do an example problem to help us figure this out. So let's say we have a circle, okay, shown here. Again, the name of this circle would be circle A, which we learned from the last podcast, and we're looking at this distance from the circle to the edge, and that distance is 6, which is our radius in this case. Okay, so we want to find the circumference, which is that total distance around the circle. Okay, so if we use our formula, the circumference is equal to 2 pi r, and in this case, our radius is 6. Okay, so radius equals 6, which we know from this diagram. Okay, so we'd say c equals 2 pi times 6. Okay, plug in 6 for our radius, and then we times that out, and we get that is equal to 12 pi. Okay, now we're going to make a quick distinction here. When we find the value of the circumference, there's two different values we want to report. There's what we call the exact value and what we call the approximate value. Okay, in this case, this answer with the pi in it is already an exact value. Okay, if we put that our answer is 12 pi for the exact circumference, that would be marked correct. Okay, because pi is an irrational number. There's no way to represent it without the symbol. Because if you try to write it out, let's write it out right here. Okay, we would say that it's equal to 3.14159, I don't remember anymore, ... Okay, and we can't write down all those digits. It goes on forever. There's no way to represent that. So pi by itself as a symbol means all the characters. So if we want the exact, and I mean exact circumference, no approximations, no rounding, we have to leave the pi in there. Okay, so there's two answers we'll put, that exact answer, and then there's the approximate answer, which makes a little bit more sense. If you try to tell someone that a circle is 12 pi in circumference, that's really hard for them to understand what you're talking about. Okay, that's not really a number we work with very often. So we can also approximate it by plugging it into our calculator. So if we took our calculator out and said 12 times pi in the calculator, it's going to give me 37.7. Okay. Now that would be the approximate distance around that circle. Now it's not exact. It doesn't have all those digits of pi in it, so we can't report it as our exact answer. So we make those two distinctions. The circumference is exactly 12 pi in distance all the way around, but approximately it's 37.7 in distance. Okay, so every time you put your answer, you're going to put two answers: the exact answer, which still has the pi symbol in it, and your approximate answer, which is what you get when you times that out on your calculator. Okay, awesome. So let's move on to our next topic. Okay, and that next topic is, what is an arc? Okay, we have our, let's say we have our circle. And when we found the circumference, we're finding this whole distance around that circle. Okay, when we're trying to find an arc, we're breaking off that circle at two very specific locations. Okay, so we're not focused so much about the distance around the whole circle. We're just looking at this small portion of the circle. What's the distance from here to there? And this is very useful in real life because sometimes we don't have a full circle that we're working with. We just have a bend or part of a circle, or it's not a perfect circle and we need to find just a portion of it. Okay, that is the case when we want to find the arc, and it's very useful to find the arc of a circle. Okay, so it's going to be a portion of this circle. So you can imagine if I drew an angle, okay, from the center, from this part of the circle, okay, and made an actual arc around. Let's say this angle is about 90 degrees. Okay. So let's say I'm trying to find this distance of the arc. How far you'd have to travel if you went from this point to this point of the circle. Okay. We're going to be able to use this angle to help us find how much of the circumference this arc is. So let's look at how we're going to calculate this. So the official formula for the arc length, okay, that distance of the arc, how far you'd have to travel along that arc, is equal to 2 pi r times the angle over 360. Okay, and again, this 2 pi r is the same as the circumference. Okay, so that's the circumference that you're finding. And then you times it by the angle over 360. Okay, so this is the angle. So if you think back to the previous slide, okay, this is the circumference, that's the angle, okay, and this proportion right here is just telling you how much of the circumference you have, because in the previous example, this was 90 degrees, right? Well, if I put that down here, 90 over 360, that's going to be equal to 1/4 when you simplify it out. Okay, if you put that on your calculator, you get the same as 1/4. And that makes sense, right? Because 90 degrees was 1/4 of the circle. Okay, 1/4 of the circle angle and 1/4 of the arc. Okay, or 1/4 of the circumference. So this proportion right here of the angle over 360 tells you how much of the circumference you need to get that arc. Okay, so let's look at a couple of examples and try this out. Okay, so let's say we have a circle. It has a radius of 3 and an angle of 60. Okay, so we're trying to find how much of this arc, okay, or how much this arc is equal to, what the value is of that arc in distance. Okay, so we're going to pull out our formula. The arc length is equal to 2 pi r times the angle over 360. Okay. Now in this case, sometimes they use this little symbol right here, which is called an alpha. Sometimes they use this symbol right here, which is called a theta. It doesn't really matter. The main thing is you're trying to find that angle. Okay, so in this case, the angle is 60. Okay, and our radius is 3. So we're going to get 2 pi times 3 times 60 over 360. Okay. So if we simplify that out, we're going to times that 3 by the 2, which gives us 6 pi. And then if you simplify this fraction right here, 60 over 360 is the same as 1/6. Okay? So 1/6 times 6 is going to give us our exact answer for the arc length, which is pi. Okay? So if we're just looking at that distance for this arc right here, it's pi. Okay? And usually there's a unit associated with it, like centimeters or feet or inches. Okay, but that's the exact distance along that arc. Okay, if we're trying to find the approximate, we just plug it into our calculator, which would give us 3.141. ... Okay. Alrighty, let's look at another example. So in this example, we're trying to find the distance of this arc right here along the outside of the circle. Okay, we know that the angle is 90 degrees, and we know that the radius is 7. So we pull out our formula. The arc length is equal to 2 pi r times the angle over 360. And so we just plug in what we know. You know that the radius is equal to 7 in this case. And we know that the angle is equal to 90. If we simplify that out, we get that we have 2 times 7, which is 14 pi, times 90 over 360. If you simplify that out, you get 1 over 4. Okay? And so then we just times 14 by 1/4. 14 over 4 is the same as 7 over 2. Okay? So 7 over 2 pi is our exact answer for the distance of that arc. Okay, if we're trying to find the approximate, we just plug that into our calculator. 7 divided by 2 times pi. That's going to give us a 10.996. Okay, about. Okay, so again, that is just telling us how long that arc is. And we know exactly how long it is and approximately how long it is. Okay? So that's the two formulas we want to know, how to find the circumference and how to find the arc length. Okay. Hopefully that made sense. Let me know if you have any questions, and thank you for watching.